In this video, I'm going to react to the James Webb Space Telescope. Hi guys, and welcome to another episode of Kabir Considers. This is the place where I react to music, media, sports, anime, anything related to popular culture. I'll watch it with an open mind and give you my 100% honest reaction to it. And if you could please hit that like button early, I'd really appreciate it. Now this is going to be a lot of fun. So this is a real personal interest of mine. You know, anything related to space, time travel, that sort of thing is a real keen interest of mine. And when I was told that the Hubble telescope was being replaced, or I'm not sure if it's being replaced or if the James Webb is going to work in tandem with it, I just knew that I had to watch a video like this. So from what I know, this new telescope, the James Webb, is the most powerful telescope in human history. It's going to basically maybe not give us a definitive answer, but it's going to help us on our journey to answering, you know, the big question that we all have. You know, are we alone in the universe? From what I've learned, it's going to use infrared to basically see like way out into the observable universe, and so it's going to be able to basically show us light that we ordinarily wouldn't see yet, or we wouldn't be able to see yet because it's not traveled close enough to the Hubble telescope. So we're going to be able to see events that are happening many billions of light years away from us. But now I feel like I might have botched that, but I think that's basically a very much simplified version of what the James Webb can do. But yeah, I just needed to watch a video like this. It's going to really break down what the James Webb is, what it's going to do, how it's going to do it. So yeah, I'm really excited for this one. Let's go. This is going to be me reacting to the James Webb Space Telescope. Let's do it.
We talked about this in the video. The new space telescope is about to fly.
This is the Hubble, right? Yeah.
Are you ready for the revolution? But the scientific progress that the launch of the James Webb Space Telescope.
Look at that. I think they actually used real gold on it. I think they used either an ounce or 2 ounces or something like that. It's probably much more, to be honest.
The telescope will bring us is so important that the topic deserves a further deepening. A deepening that we decided to do, trying to imagine what questions each of you would want to ask NASA. You all agree? So let's get started.
Let's go.
What is the James Webb Space Telescope? The James Webb Space Telescope, also called Webb or JWST, is a large space-based observatory optimized for infrared wavelengths.
Ah, yes, as I suspected. So they are using infrared light. So basically, is that related to heat signatures, I think?
Which will complement and extend the discoveries of the Hubble Space Telescope.
So it is working in tandem with the Hubble.
It will be launched in space on October 31st this year. It will have longer wavelength coverage and greatly improved sensitivity. The longer wavelengths enable Webb to look further back in time to find the first galaxies that formed in the early universe.
Wow.
And to peer inside dust clouds where stars and planetary systems are forming today. The James Webb Space Telescope was originally called the Next Generation Space Telescope, or NGST. It was called Next Generation because Webb will build on and continue the science exploration started by the Hubble Space Telescope.
Nice.
Discoveries by Hubble and other telescopes have caused a revolution in astronomy and have raised new questions that require a new, different, and more powerful telescope. Webb is also a next-generation telescope in an engineering sense.
I love this sort of a honeycomb design that it's got going on here. Really cool. I wonder how durable it is though, because I imagine if it's going to be in space, there might be, obviously I know the vacuum of space is vast, but there might be like debris flying in its direction. So I hope it can, but I guess they can veer it off in different directions.
Introducing new technologies like the lightweight deployable primary mirror that will pave the way for future missions. On September 10, 2002, the Next Generation Space Telescope was named in honor of James E. Webb, NASA's second administrator.
Nice.
What are the main science goals of Webb? Webb has 4 mission science goals. Search for the first galaxies or luminous objects that formed after the Big Bang. Determine how galaxies evolved from their formation until the present. Observe the formation of stars from the first stages to the formation of planetary systems. Measure the physical and chemical properties of planetary systems and investigate the potential for life in those systems.
Wow. So those are 4 quite big objectives, especially this last one. Measure the physical and chemical properties of planetary systems and investigate the potential for life in those systems. It's just crazy that, a telescope is going to be able to do all of these 4 things.
How big is it? The most important size of a telescope is the diameter of the primary mirror, which is about 6.5 meters for Webb.
Wow.
This is about 2.75 times larger in diameter than Hubble, or about 6 times larger in area. The Webb will have a mass of approximately 6,500 kilograms, a little more than half the mass of Hubble.
Wow, so the mirror is more than twice the size, yet the overall mass is much less. That's efficiency right there.
The largest structure of Webb will be its very big sunshade, which must be able to shield the deployed primary mirror and the tower that holds the secondary mirror. But how is it that Webb, with a mirror 6 times the size of Hubble, only weighs half as much? The reason is quite simple. There has been a lot of progress in technology since Hubble was built. The best example of weight reduction is the primary mirror, which takes up a considerable fraction of the total observatory mass. Hubble has a thick, solid glass mirror with a mass around 825 kilograms. Webb's mirror will consist of 18 thin, gold-coated beryllium mirror segments, which will be kept in the right shape and placed by a large number of adjusters attached to a stiff backing frame. Including the backing frame, the 18 segments of the Webb primary mirror total about only 625 kilograms.
Wow.
These kinds of technologies, which were not available at the time Hubble was built, will be used throughout Webb.
I imagine beryllium is maybe a composite that wasn't available back when the Hubble was first created. So it's probably maybe a new material.
Why does Webb have a segmented, unfolding primary mirror? Webb needs to have an unfolding mirror because the mirror is so large that it otherwise cannot fit in the launch shroud of currently available rockets. Designing, building, and operating a mirror that unfolds is one of the major technological developments of Webb. Unfolding mirrors will be necessary for future missions, requiring even larger mirrors, and will find application in other scientific, civil, and military space missions. Why is Webb optimized for near and mid-infrared light? The primary goals of Webb are to study galaxy, star, and planet formation in the universe. To see the very first stars and galaxies,
I'm just transfixed by this shot, I imagine each little dot of light is a star, in this, or maybe a moon as well, but just, you can't even count the number of little dots of light in this picture. And this picture probably makes, such a tiny percentile of what's out there. Let me know, what do you think, guys? Do you think that we're alone out there? I know I've asked this question on the community tab before, but let me know if you think we're alone, because I don't think it's possible. The amount of suns out there, the amount of planets in habitable zones, I just don't know. I don't think it's possible that we're alone out there.
Galaxies form in the early universe. We have to look deep into space to look back in time, because it takes light time to travel from there to here. The farther out we look, the further we look back in time. The universe is expanding, and therefore the farther we look, the faster objects are moving away from us, redshifting the light. Redshift means that light is emitted as ultraviolet or visible light is shifted more and more to redder wavelengths, into the near and mid-infrared part of the light spectrum for very high red shifts.
Right.
Therefore, to study the earliest star formation in the universe, we have to observe infrared light and use a telescope and instruments optimized for this light.
For infrared, yeah.
Star and planet formation in the local universe takes place in the centers of dense, dusty clouds, obscured from our eyes at normal visible wavelengths. Near-infrared light, with its longer wavelength, is less hindered by the small dust particles,
I see, so it's more visible.
allowing near-infrared light to escape from the dust clouds. By observing the emitted near-infrared light, we can penetrate the dust and see the progresses leading to star and planet formation. Objects of about Earth's temperature emit most of their radiation at mid-infrared wavelengths. These temperatures are also found in dusty regions, forming stars and planets. So with mid-infrared radiation, we can see the glow of the star and planet formation taking place. An infrared-optimized telescope allows us to penetrate dust clouds.
What is this? Is this are these cosmic rays, or is this purely infrared? It's just crazy. If this is infrared, like, you can't see it with the naked eye, yet it's happening all around us. Just look at all of this. It looks like lava.
To see the birthplaces of stars and planets. Why do we have to go to space at all? Can we not get this data with large telescopes on the ground using adaptive optics? The Earth's atmosphere is nearly opaque and glows brightly at most of the infrared wavelengths that Webb will observe, so a cold telescope in space is required. For those wavelengths that are transmitted to the ground, the Earth's atmosphere blurs the images and causes stars to twinkle. Currently, adaptive optics systems can correct for this blurring only over small fields of view near bright stars functioning as reference beacons, allowing access to only a small fraction of the sky. Artificial light beacons created with strong lasers may provide better access to the sky, but the technology to provide a wide field of view is still far in the future. Finding the earliest galaxies will require very low foreground light levels, ultra-sharp images over large areas, and studies at many infrared wavelengths.
I remember somebody told me once that there's more planets or galaxies in the universe than there are grains of sand on Earth. And obviously there's an incalculable amount of sand. It's just like, in a way, it kind of makes me sad that we're not, like, all of us, we're kind of born too early to go and voyage, the solar system, not the solar system, but the galaxy and the universe. Maybe one day.
A combination of observing conditions only available from space. How faint can Webb see? Webb is designed to discover and study the first stars and galaxies that formed in the early universe. To see these faint objects, it must be able to detect things that are 10 billion times as faint as the faintest stars visible without a telescope. This is 10 to 100 times fainter than Hubble can see.
Crazy.
Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. What is Webb's angular resolution, and how will its images compare to Hubble's? Will they be as beautiful? Angular resolution is the term astronomers use to describe the sharpness of an image.
But the thing is, because this is a infrared telescope, is it going to be able to take images in the traditional sense, or is it just going to be kind of blotches of light where, that infrared signature is being detected?
There are two factors that affect how sharp an image is: the diameter of the mirror and the wavelength being observed. Webb's angular resolution will be the same as Hubble's, but in the near infrared. This means that Webb's images will appear just as sharp as Hubble's do.
Okay.
Webb will have an angular resolution of somewhat better than 0.1 arcseconds at a wavelength of 2 micrometers. 1 degree equals 60 arc minutes equals 3600 arcseconds.
What is an arcsecond? If anyone in the comment section knows what an arcsecond is, let me know. I'd really appreciate it.
Seeing at a resolution of 0.1 arcsecond means that Webb could see details.
Oh, he's about to answer the question.
Details the size of a US penny at a distance of about 40 kilometers.
What? So the Webb could see details the size of a US penny, so something like that big, at a distance of 40 kilometers. So that's like a marathon away.
With some infrared capability, Hubble is still capturing gorgeous images, but Webb is optimized to see deeper into the infrared than Hubble, and has a much larger mirror, as well as state-of-the-art detectors. Its imagery will be detailed and spectacular. Hubble's detectors actually produce images in shades of black and white. Color is added during image processing. The colors aren't always what we'd see if we were able to visit the image objects in a spacecraft. Color is a tool which can enhance an object's detail or visualize what could have never been seen by the human eye. Webb image processing will be similar. Webb will have two types of detector arrays: visible to near-infrared arrays with 2048 by 2048 pixels, and mid-infrared arrays with about 1024 by 1024 pixels. Will Webb see planets around other stars? The Webb will be able to detect the presence of planetary systems around nearby stars.
Look at all of these stars, man. And to think each star could have its own sort of little solar neighborhood like we've got with our solar system. Just so many planets.
Stars from their infrared light.
Like, imagine if there's a planet out there right now with people on it, wondering if they're alone. Isn't that a crazy thought?
Heat. It will be able to see directly the reflected light of large planets, the size of Jupiter, orbiting around nearby stars. It will also be possible to see very young planets in formation while they are still hot. Webb will have coronagraphic capability, which blocks out the light of the parent star of the planets. This is needed as the parent star will be millions of times brighter than the planets orbiting it. Webb will not have the resolution to see any details on the planets. It will only be able to detect a faint light speckle next to the bright parent star. Webb will also study planets that transit across their parent star. When the planet goes between the star and Webb, the total brightness will drop slightly. The amount that the brightness drops tells us the size of the planet. Webb can even see starlight that passes through the planet's atmosphere, measure its constituent gases, and determine whether the planet has liquid water on its surface. When the planet passes behind the star, the total brightness drops, and we can again determine more of the planet's characteristics. Can Webb observe planets in our own solar system? Yes. Webb can observe anything in our solar system that is further from the Sun than the Earth is. Webb's sensitivity will be most useful in studying the faint rocky and icy objects in the far outer solar system, including the dwarf planet Pluto and other Kuiper Belt objects. I thought Pluto had been declassified as a planet. I thought that we now refer to Pluto as a moon. So have we reclassified it then? Studies of these objects will test theories of how the solar system formed. Webb will also observe the moons of the gas giant planets, comets and asteroids, and the planets Mars, Jupiter, Saturn, Uranus, and Neptune. Why has the Ariane 5 been chosen to launch Webb? Why not change to SpaceX?
Yeah, good question.
The James Webb Space Telescope will be launched on an Ariane 5 rocket. The launch vehicle is part of the European contribution to the mission.
I see.
The Ariane 5 is one of the world's most reliable launch vehicles, capable of delivering Webb to its destination in space. The Ariane 5's record for successful consecutive launches is 80 as of June 28, 2017. European Space Agency provides NASA with a launch vehicle and associated services. In exchange, NASA guarantees European scientists a fraction of observing time on Webb, roughly 15%. Webb will be launched from Ariane Space ELA-3 launch complex at European Spaceport located near Kourou, French Guiana. Why can't Webb be repaired like Hubble in case of damage? Hubble is in low Earth orbit, located approximately 600 kilometers away from the Earth, and is therefore readily accessible for servicing. Webb will be operated at the second Sun-Earth Lagrange point, located approximately 1.5 million kilometers away.
1.5 million kilometers away. Yeah, we're not getting to that in a hurry.
Away from the Earth, and will therefore be beyond the reach of any crewed vehicle currently being planned for the next decade. In the early days of the Webb project, studies were conducted to evaluate the benefits, practicality, and cost of servicing Webb either by human spacecraft flight, by robotic missions, or by some combination such as retrieval to low Earth orbit. Those studies concluded that the potential benefits of servicing do not offset the increases in mission complexity, mass, and cost that would be required to make Webb serviceable. or to conduct the servicing mission itself. Webb requires a distant orbit for several reasons. Webb will observe primarily the infrared light from faint and very distant objects. Infrared is heat radiation, so all warm things, including telescopes, emit infrared light. To avoid swamping the very faint astronomical signals with radiation from the telescope and its instruments must be very cold.
Yeah.
Webb's operating temperature is less than 50 degrees above absolute zero.
Wow. That is crazy. Because absolute zero, that's like minus 280, I think it's 287 Celsius, which is just unimaginably cold. So this is operating at what? Minus 237. How do they do stuff like this, like scientists? It's just, those guys are amazing.
50 Kelvin, minus 223 degrees Celsius.
Minus 223. I was fairly close.
Therefore, Webb has a large shield that blocks the light from the sun and Earth and the moon, which otherwise would heat up the telescope and interfere with the observations. Webb will be placed in orbit around the sun at a special location where its sun shield can block both the sun and Earth and moon all the time. The cold and stable temperature environment of the L2 point will allow Webb to make the very sensitive infrared observations needed. What happens after Webb is launched? In the first hour, starting at liftoff, the Ariane rocket will provide thrust for a little over 8 minutes. Webb will separate from the Ariane 5 launch vehicle a half hour after launch and deploy the solar array immediately afterwards. In the first day, 2 hours after launch, Webb will deploy the high-gain antenna. 12 hours after launch, there will be the first trajectory correction maneuver by small rocket engines aboard Webb itself.
I imagine it's like a delicate game of origami, just, delicately just opening up, and like all of the segments of the mirror, that honeycomb shape, just individually popping out. Really sensitive stuff.
In the first week, the second trajectory correction maneuver will take place at 2.5 days after launch. Webb will start the sequence of major deployment just after that. The first deployments are the fore and aft sunshield pallets, followed by the release of remaining subsystem launch locks. The next deployment is the telescope, in which the telescope and the spacecraft busts move apart from each other by about 2 meters when the deployable tower assembly extends. The full sunshield deployment with unfolding and tensioning of the membranes can then be initiated.
Wow.
At 6 days, Webb deploys the secondary mirror, followed by the side wings of the primary mirror. In the first month, as the telescope cools down in the shade of the deployed sunshield, we will turn on the warm electronics and initialize the flight software.
Wow, so it's going to take a month after launch for everything to get to the point where we can start switching it on. I guess, it's for the amount of time people have been waiting for the Webb to go up, another month isn't, it's like a drop in the bucket, really.
At the end of the first month, we will do the mid-course correction that ensures that Webb will achieve its final orbit around L2. In the second month, and 33 days after launch, the first image will be of a crowded star field to make sure that light gets through the telescope into the instruments. Since the primary mirror segments will not yet be aligned, the picture will still be out of focus. At 44 days after launch, NASA will begin the process of adjusting the primary mirror segments, first identifying each mirror segment with its image of a star in the camera. We will also focus the secondary mirror. In the third month, from 60 to 90 days after launch, we will align the primary mirror segments so that they can work together as a single optical surface.
Nice.
By the end of the third month, we will be able to take the first science quality images. After 6 months,
Can't wait
Webb
to see
will begin
those.
its science mission and start to conduct routine science operations. So remember all this next Halloween, when the future of astronomy will be changed forever.
Exciting times. That was fascinating. Honestly, just the work that NASA, the European Space Agency, and its partners do is just absolutely incredible. It's exciting to me because it's almost like it's going to answer or help us answer a lot of questions that we have about not just are we alone, but just what is out there, what kind of planets are out there, what do the galaxies that were formed shortly after the Big Bang, what do they look like, you know, how fast are they moving? It's just really, it's almost like a new era of space well, it is a new era of space telescopes, but just a new era of space exploration in general, like not just with the James Webb, but with what's going on with SpaceX and Starship, and Amazon with Blue Origin. You know, it feels like a new space race is starting, and and as a guy who's interested in space exploration, it's really, really exciting times for sure. Thanks for watching, guys. If you enjoyed this video, please like, subscribe, turn on bell notifications, and keep throwing the recommendations my way. I know I say it all the time, but they genuinely help me out, because if I know you enjoyed watching something, I'll definitely enjoy reacting to it. So like, subscribe, turn on bell notifications, keep throwing the recommendations, and I'll catch you in the next one.